Hello students, I welcome you all on behalf of Resonance. This is SP Raghuvanshi, SPR sir. I am head of department chemistry here in Resonance. We already have got the paper of JEE Advanced 2021 and this is the official paper. So I will be discussing the chemistry paper and especially the inorganic and physical part of this particular paper in this session. So the first question, this is a single choice question from the organic chemistry. Organic chemistry questions will be discussed in another session. So we will be focusing only on discussion of physical and inorganic chemistry questions. First question HCQ from organic chemistry and second question is also HCQ of organic chemistry. Next question, third question, it's a HCQ question, single choice question. It's of 3 marks and negative marking is also there. -1 will be deducted if you will be answering wrong option. It's a question from solid state. Given a closed package structure of a salt made up of cation X and anion Y, ions of only one phase are shown for the clarity. So Y atoms are present at the corners and X atoms are present at the phase center. So we want to calculate the packing efficiency, packing fraction. What is the packing fraction approximately? So we can do the calculations for this particular question. The calculations are going to be in this manner. We can calculate the edge length of the unit cell. Since the atoms of Y are also touching each other according to the figure. So edge length is also going to be 2 times the radius of the Y atoms. And we can calculate the phase diagonal. Phase diagonal is going to be √2 times A, that is equal to 2 times radius of Y atom plus radius of X atom. So this way we can calculate the relation between the radius of X atom and radius of Y atoms. We can easily see that √2 minus 1 times A is equal to 2 times radius of X and A is equal to 2 times radius of Y. So that way √2 minus 1 into radius of Y is equal to radius of X. And we already know that X is present in the, we can say, octahedral void and it's of fitting size. So that way radius of X is equal to 0.414 times radius of Y. Now if this is the situation in the solid, then we can calculate effective number of Y atoms in the solid and effective number of X atoms in this solid. So according to the figure, Y atoms are present at the corners only. So that way number of Y atoms, effective number of Y atoms is going to be 1 and X atoms are present at the phase centers. One phase center will contribute half X atom into one unit cell. So number of X atoms is equal to 3 and number of Y atoms per unit cell should be equal to 1. So now we can calculate the total volume of the atoms X and Y and the total volume of unit cell, and that is going to be packing fraction. So packing efficiency is going to be 3 times 4/3 pi radius of X ka cube plus 1 into 4/3 pi radius of Y ka cube, this divided by A cube. This is going to be packing fraction. So if this calculation, we know now the values of radius of X and Y in terms of A. So we can substitute and calculate the packing fraction. This will come out to be approximately 0.63. It will be more than 0.52, the packing fraction of cubical unit cell, because X atoms are extra present. It is not equal to 0.74, that is closed pack efficiency. So that way we can reject the option A, C and D and the correct option is going to be B, and after calculation we can confirm it. So it is a question, single choice question from solid state. Calculations are involved, but it is not that difficult question. We can say it is easy to moderate question. Question number 3 from solid state. Next question in the paper, question number 4. This is from inorganic chemistry, coordination compounds. The calculated spin only magnetic moment of this complex, this is hexaamine chromium complex and this is hexafluoridocuprate complex. We want to calculate the number of unpaired electrons. So we know that chromium is present in +3 oxidation number, plus 3 chromium is going to be D3 configuration, and copper is present in plus 3 oxidation number. So, this is D8 configuration. Now, we can easily calculate number of unpaired electrons. In D3 configuration, there will be 3 unpaired electrons, n equal to 3, and in D8 configuration, there is going to be 2 unpaired electrons. Now, we know the spin only magnetic moment is given by root of n into n plus 2 Bohr magneton unit. So, for n equal to 3, this first spin only magnetic moment is going to be 15 root 15 Bohr magneton, and this is going to be root of 2 into 4, that is root 8 Bohr magneton. So, that is why the spin only magnetic moments are close to 4 and 9. So, A is going to be correct option. Now, this is a simple question from coordination compounds. We simply have to calculate number of unpaired electrons in these complexes. So, it is a 3 mark question, easy 3 marks we can say. Next question in JEE paper was question number 5 and 6 based on this question stem. So, this is a new pattern introduced in this particular JEE paper only, in 2021 paper, in which a question stem is given, and based on this data given, we have to answer 2 numerical answer type of questions. So, question number 5 and 6, these are from organic chemistry. So, will be discussed in another session. This is question number 5, and this space is for question number 6. The value of x and y we have to calculate. Next is the question number 7 and 8. These questions are from physical chemistry. The reaction X solid into Y solid and Z gas. This reaction is given. The plot of ln partial pressure of Z upon P naught versus 10 to the power 4 upon T is given. This graph is given to us, given below, and we want to Pz is the partial pressure of gas Z. So, based on this information given to us, we have to calculate the next quantity, that is the value of standard enthalpy delta H naught for the given reaction. So, the reaction is given to us, this reaction X solid giving us Y solid and Z gas. For this reaction, we want to calculate delta H naught. This equation is also given to us, d ln k by d 1 upon T is equal to minus delta H naught of delta H naught by R. So, this equation is already known to us. The equilibrium constant is equal to partial pressure of Z only, that is also known to us, the fact is known to us. So, we have to let us say read this graph and answer the question. So, we already know that d ln k is equal to minus delta H naught upon R into d of 1 upon T. If we integrate this equation, then we will be getting this type of equation, ln k is equal to minus delta H naught upon RT plus some constant. This constant is also known to us, ln k is equal to as such minus delta H naught upon R plus RT plus delta S naught upon R. The constant we can calculate. So, based on this equation, we can calculate the value of delta H naught of the reaction, and next question, question number 8 is calculation of delta S naught of the reaction. Now, from the graph, we have to read the graph. From the graph, the slope, we have to calculate the slope. The slope of this straight line, that is delta y upon delta x, is going to be this is 4 units and this is 2 units only. So, we can substitute the value, that slope, we can read that slope is equal to minus delta H naught upon R. But we have to do one modification, since the graph is plotted between ln k and on the x axis we have taken 10 to the power 4 upon T as the x coordinate. So, what we can do, we can write this is minus delta H naught upon R and multiply it with 10 to the power 4 on in numerator and denominator both. So, this way this is going to become the equation Now x coordinate, we have taken the x coordinate to be 10 power 4 upon t. So, this is the x coordinate and this is the y coordinate. So, this is x coordinate and this is y coordinate. So, this way slope is going to be minus delta h naught upon r into 10 raised to power 4. So, we can write the slope of the straight line to be equal to minus of delta h naught upon r into 10 raised to power 4. And the slope is, we can read the graph and the slope is coming out to be on the y axis this is 4 units, on the x axis 2 units. So, this is minus 4 by 2. So, we can calculate delta h naught of the reaction to be equal to minus 2 r into 10 raised to power 4. We can substitute the value of r to calculate the value of delta h naught. So, this way this is equal to minus 2 into 8.314 into 10 kilojoule per mole. So, this is going to be the correct answer for delta h naught of the reaction. So, this is a very good question from, we can say, thermodynamics or from chemical equilibrium. We should be knowing this relation, and based on this relation the calculation of delta h naught of the reaction can be done. Next question based on this paragraph only is question number 8, in which we want to calculate delta S naught of the same reaction at 1000 Kelvin, delta S naught of the reaction at 1000 Kelvin. Now, we know the equation that ln K is equal to minus delta H naught upon RT plus delta S naught upon R. So, if this is taken as a, let us say, straight line, then we can write down the equation of a straight line as y is equal to mx plus c. Then c is going to be the y coordinate, c is going to be, let us say, the y intercept, sorry. So, we can substitute the values of x and y to calculate the value of c. So, let us substitute the value ln k. One of the point in the graph, this type of graph is given to us. The straight line is passing through the position number minus 3 and this is I think the value is 10, that is correct, and the x axis is 10 raised to power 4 upon t is going to be the x coordinate. So, let us substitute the values. So, this way this ln k is equal to minus 3 is slope is equal to of 2 units into x is equal to 10 plus c. So, the slope is equal to minus 2, I should be substituting slope with sign. So, this way c is coming out to be 17. So, 17 is going to be the value of delta S naught by R. So, this way delta S naught upon R is equal to 17 units. So, delta S naught of the reaction should be equal to 17 times 8.314, that is in SI units. Question is very good question from chemical equilibrium and thermodynamics. We have to read the graph and we should be knowing the equation. Using this equation, we can calculate the slope and the y intercept, and the value of slope and y intercept is going to give us delta H naught and delta S naught of the reaction. Question number 7 and 8 from chemical equilibrium and thermodynamics. Next question is time. This question is from colligative properties. Boiling point of water in a 0.1 molal silver nitrate solution, solution A, is equal to x degree centigrade, that is boiling point. Now, the Kb is given to us 0.5, the value of Kb is equal to 0.5. So, we can calculate the value of x easily because x is the boiling point. Now, boiling point elevation delta Tv we can calculate. Delta Tv is equal to molality, that is 0.1 molal. Silver nitrate is 100% dissociated. So, its want of factor will be 2 into Kb, that is equal to 0.5. So, delta Tv will be equal to 0.1, that is elevation and boiling point. So, solution A ka boiling point is going to be 100 degree centigrade plus elevation. So, the boiling point x this value of x is coming out to be 100.1 degree centigrade. So, x is equal to 100.1. That should be one of the numerical based on this paragraph. Next is to this solution A, an equal volume of 0.1 molar aqueous barium chloride is added. So, we are adding barium chloride into this. So, barium chloride will react with silver nitrate and AgCl white PPT will get formed. So, the number of ions in the solution will get reduced as such. So, we have to calculate the number of ions of different number of ions or different number of particles of different species in the solution. So, that is solution number B, and we want to calculate the boiling point of solution number B. Now, Y is the difference in the boiling point of solution number A and B. So, Y into this is difference in boiling point. That is not boiling point, Y is not boiling point of solution number B. So, now we can do the calculations for solution number B also. So, X is 100.1 degree centigrade. That is a simple question, the calculation of X from colligative properties. So, first question based on this system is the calculation of X only. What is the value of X? So, this is 100.1 degree centigrade. X is 100.1. Next question is the calculation of Y. What is the value of Y? So, we have to write down the reaction that silver nitrate from the solution number 1A will react with barium chloride and there will be formation of AgCl PPT and barium nitrate. This is going to be the reaction. Now, the number of moles of silver nitrate are 0.1 molar. So, we can take, let us say we have taken 1 kilogram of the solution, or it is more precise, one solution that which is containing 1 kilogram of water. In that solution 0.1 mole of silver nitrate are present and 0.1 moles of barium chloride are added into it. Initially this will be 0 and this will be 0. Reaction is going to be 100% complete. This is going to be limiting reagent. So, we can assume that this is 100% consumed. This is 0.05 moles of barium chloride will remain. PPT will get formed. So, we need not write the number of moles of AgCl formed, and barium nitrate, how many moles? 0.05 moles of barium nitrate will be there. So, this is 100% dissociated, this is 100% dissociated. So, total moles of all ions, we can calculate total number of moles of all the ions. So, this is going to be 3 into 0.05 plus this is also 3 into 0.05 barium nitrate, 1 cation, 2 anions are there. Barium chloride similarly 1 cation, 2 anions are there. So, this is 0.15 plus 0.15, 0.3 moles in total. 0.3 moles are present, that is total number of moles of all different ions. Now, the total volume of the solution has got doubled because we have added equal volume of this solution into this solution, or we can say total mass of water have got doubled. So, we can say effective molality, that will not be equal to total number of moles of the all different species, it will be half of that because total volume or total mass of the water present in the solution, that is double. So, that way this is equal to 0.15 moles. So, we can say this solution is going to act as 0.15 molar solution. The solution X was 0.2 molar solution effectively, and this solution is acting as 0.15 molar solution only. So, we can calculate difference in the boiling point. So, this difference in boiling point of both these solutions, difference in boiling points, that will be equal to difference in the molality 0.2 minus 0.15 into Kb of water. So, this is 0.5. So, this way this is coming out to be 0.2 minus 0.15 is 0.05 into 0.5. So, this is 0.025. Now, y is given to, the difference is given to us as y into 10 raised to power minus 2. So, this way the value of y should be equal to 2.5. So, correct answer to this question should be 2.5. This is definitely a better question in comparison to question number 9. So, this is again based on colligative properties only. We have to do the calculation we have to calculate the effective number of particles in the solution, and after this calculation we will be getting the answer. I think it should be clear. Colligative properties, not a tough question, but definitely 10th question is involving some calculations. Next question from physical and inorganic, question number 11 is of organic chemistry. Question number 12 is also from the organic side. Question number 13, this is related to colloids. It is a question from the surface chemistry. Correct statement related to colloids. The process of precipitating colloid by an electrolyte is called peptidization. No, that is not correct. We know that peptidization is the method of forming colloidal solutions. The precipitate is brought into colloidal state by the method of peptidization. This is incorrect statement. Colloidal solution freezes at higher temperature than the true solution at same concentration. Freezing point or depression in freezing point, that is a colligative property that depends only on the concentration. So, if the concentration is same, then depression and freezing point should be same. So, that way these two solutions should have same freezing point. It should be incorrect. Surfactants form Michel, above critical Michel concentration, that is correct, and CMC depends on temperature, that is also correct. So, this is a correct statement. CMC depends on temperature. Actually CMC on increasing temperature first decreases then increases, but it depends on temperature. So, C is correct statement. Michels are macromolecular colloids. No, that is not correct. Macromolecular, that is not correct, because smaller particles will be aggregating to form a Michel. So, it is a multimolecular colloid, we can say. So, this should be incorrect. So, in this case I think only C is the correct option. So, surface chemistry question, definitely we can say it is of medium level, different statements should be known to us. Next question, this is a question from thermodynamics, question number 14. An ideal gas undergoes a reversible isothermal expansion from state 1 to state 2. First reversible isothermal expansion followed by reversible adiabatic expansion. Then the correct plot. So, A is correct, we all know. This is isothermal expansion and this is adiabatic expansion. So, A is correct statement. B is definitely incorrect. This is not isothermal. 1 to 2, that is isothermal. 2 to 3 is adiabatic. So, adiabatic expansion, if this is expanding then temperature will be decreasing, and if this is expanding then pressure is going to decrease. So, 1 to 2 is going to be isothermal expansion. If expansion is there then pressure will be decreasing. So, this part is correct. Now, next is adiabatic expansion. Adiabatic expansion, temperature will decrease and as well as pressure will also decrease. So, this part is also going to be true. So, B should be a correct statement. The correct graph, 1 to 2 isothermal and expansion, temperature will remain constant, but expansion pressure will decrease. Then 2 to 3 and 2 to 3 temperature will decrease, adiabatic expansion, and pressure will also decrease in adiabatic expansion. So, B is correct graph. C, H, between enthalpy and entropy, the graph is between enthalpy and entropy. So, 1 to 2 enthalpy is remaining constant, that is isothermal, should be correct. 2 to 3 adiabatic means isoentropic. So, entropy should remain constant, that is correct, but entropy should increase, but entropy should remain constant, sorry, temperature will decrease. So, if temperature is decreasing then enthalpy should be decreasing, but it is shown to us as increasing. The correct graph would have been this: first isothermal enthalpy remaining constant, then entropy will remain constant, enthalpy will be decreasing, sorry, isothermal enthalpy will remain constant, then adiabatic expansion, entropy will remain constant, but enthalpy will decrease because temperature is decreasing. So, this would have been correct graph. C is incorrect. D, isothermal, correct, and then second to 3 is temperature decreasing, but entropy remaining constant, that is adiabatic, temperature will decrease, entropy will remain constant, it should be correct. So, correct answer for this particular question should be A, B, D. it's a very good question from thermodynamics. A, B, D is definitely we have to analyze all these graphs. So, it's a good question. Thermodynamics, graphical question. It's not easy to read graphs. So, it's a tough question, I should say. Next is question number 15, the correct statement related to metal extraction process. It's a question from metallurgy. A mixture of lead sulfide and lead oxide undergoes self reduction to produce Pb and SO2. That is correct. Lead can be obtained by self reduction of its ore. So, PbS and PbO will undergo self reduction. In the extraction of copper from copper pyrites, silica is added to produce copper silicate. It should not be copper silicate. Silica is being added to remove the impurity of ferrous oxide. It should be ferrous silicate, not the copper silicate. So, it should be incorrect. We are not adding silica to convert copper into copper silicate, copper pyrite, or to let us say convert copper into copper silicate. Copper is the main metal which we want to extract. So, impurity of iron is getting converted into silicate. Partial oxidation of sulfide ore of copper by roasting followed by self reduction, blister copper is produced. That is correct. It's correct statement. In cyanide process, zinc powder is utilized to precipitate gold from this dicyanido-orate complex. That is also correct. So, A, C, D are the correct statements. So, this is a question from metallurgy, metallurgical extraction. These statements are known to us. Is question number 17, maximum number of possible isomers. That is from organic. So, we will be discussing it in the next session, another session. Next question in paper 1 is also from organic chemistry. Then next question is question number 19 from inorganic chemistry. Total number of possible isomers for this complex. So, we have to consider all different possible isomers of this formula. The formula is this is tetraamine dichlorido platinum complex, and bromine is present in the ionization sphere. Sorry. Now, this formula itself will show geometrical isomerism. So, there will be two isomers for this formula, cis and trans. Now, it can also show ionization isomerism. So, that way we can have another compound with the same molecular formula. This is Cl and one Br is inside the coordination sphere, and if this is the situation, then in this case also this compound will have two isomers, cis and trans. So, cis and trans are also possible with this formula, and we can have another ionization isomer for this particular formula, in which both the bromines are inside the coordination sphere and two chlorines are outside it. This particular formula will also show geometrical isomerism, cis and trans. So, this way total number of isomers will be equal to 6. So, 6 is going to be the correct answer for this particular question, total number of isomers possible for this formula. So, these were 19 questions from paper number 1 of JEE Advanced paper. So, this discussion will definitely be helpful to you in, let us say, analyzing your paper. Tomorrow we will be preparing the solution in more detailed manner, and those solutions will be on much better platform also. But the immediate answer key and the immediate explanations of this particular paper must be going to be helpful to you. That is all for discussion of paper number 1, and in the next session I will be discussing physical and inorganic questions for paper number 2. Thank you.